lesson for today, I want to review how to solve absolute value equations and inequalities. This will be page 24 in your notebook. If you'll please get yourself a sheet of notebook paper, we're going to do these 4 problems on your sheet of notebook paper. These are skills that you learned in Algebra 1, so for some of you it's been quite a while. So what we'll do is we'll solve these equations and I'll try to go through the steps. The first thing I want you to make note of, at least mentally, if not physically, you could write yourself a little note. Absolute value is the distance from 0. When you're measuring distance, we never measure distance with a negative number. So that means that if the absolute value of an algebraic expression equals a negative number, then that's not possible. You would write no solution. We're safe here because the absolute value of x minus 1 equals 2. What we do know is that I can take the absolute value of a negative number. In fact, I can go one step further and say the number that I'm taking the absolute value of has to be either positive 2, because the absolute value of 2 is 2, or it has to be negative 2, because the absolute value of negative 2 is 2. When you have an absolute value problem, you write 2 equations. You find the value of the algebraic expression x minus 1 when it equals 2, and you also find the value of x when this algebraic expression equals negative 2. You do not put the absolute value symbols here. Here we're just simply trying to find what x is if positive 2 were inside this absolute value. And here we're just trying to find the value of what x is if negative 2 were the value inside the absolute value. Now we'll solve both of those. We'll add 1, x equals 3, or we'll add 1 also, x equals negative 2 plus 1 is negative 1. Let's check that really quickly. 3 minus 1 is 2. What's the absolute value of 2? 2. Negative 1. Negative 1 minus 1 is negative 2. What's the absolute value of negative 2? 2. So my 2 solutions, and never put them in an ordered pair, my 2 solutions are negative 1 and 3. The solutions are typically put in numerical order. Please, please, please never ever do this. That is incorrect. This is correct. Let's look at question 2. For question 2, I can't do any of this that I did on this line until my absolute value is alone. I need to isolate this expression. I need to get rid of minus 2 and multiplying by 3. I'll get rid of that minus 2 first by adding 2 to both sides. So I'll have 3 times the absolute value of 2x plus 5, that's gone, equals 9. Now I need this expression to be alone that's inside the absolute value. It's not alone yet. I'll divide both sides by 3. So the absolute value of 2x plus 5 is equal to 9 divided by 3, which is 3. Try to remember to always check once you have your absolute value isolated to see if this number is positive. It is, so I may continue. And I'll continue up here. I'm trying to find when this expression 2x plus 5 is equal to positive 3, or when that expression 2x plus 5 is equal to negative 3. I'll solve each of these equations. X will equal negative 1 here. Subtracted 5. Divide by 2. X will equal negative 4. And let's check those. 2 times negative 1, negative 2. Negative 2 plus 5, positive 3. The absolute value of positive 3, 3. 3 times 3 is 9. 9 minus 2 is 7. Negative 1 is a solution. Let's try negative 4. 2 times negative 4, negative 8. Negative 8 plus 5, negative 3. The absolute value of negative 3, 3. 3 times 3, 9. 9 minus 2, 7. Both of those are my solutions. The solutions are, and I'll just put them in numerical order, smallest to largest, negative 4, negative 1. Moving on to the inequalities, they're just a little bit different. You have to remember which conjunction that you have, and just like in English, you have conjunctions that connect complete sentences in English. In mathematics, you have conjunctions that connect mathematical thoughts. The conjunctions that we use are and, or. If you'll notice up here, I used or. When you have equals, you always use or. But when you're talking about inequalities, when you see the less than symbol or the less than or equal to, that is an and conjunction. When you see greater than or equal to, that is an or conjunction. These two types of inequalities are written differently when you're using these conjunctions. Let's do the or problem first. Which of these two is an or? Hopefully you mentally said this one. That is correct. I do want to get this absolute value alone before I can continue. So I'll subtract 7 and divide by 5. Next, to do this problem, I take 4x greater than or equal to 4, or 4x, I make this a negative 4, just like we did up here, because we know the value inside can be 2 or negative 2, so it's no different when you do this problem down here. You do this expression with positive 4 and this expression with negative 4. The difference, however, is that I must flip this inequality over. I'm going to solve each of these. Solve this one. Now, an or problem, when graphed, I don't think it says you have to graph, but I want to show you, hopefully to remind you from Algebra 1. I have positive 1 and negative 1. They're both equal to, so I'll be solid. Greater than or equal to 1, less than or equal to negative 1. I want to write this answer in interval notation. On a number line, to the far left is negative infinity, and to the far right is positive infinity. So as I read this number line from left to right, the shading, the purple shading, begins at negative infinity. I always use parentheses at infinity and negative infinity. That shading continues until I get to negative 1, so I put a comma. I have a solid circle, so I put a bracket. Or is a union, so I put a U. And then I put a bracket. I pick up the shading again at negative 1. And it stops technically at infinity with the parentheses. This is the answer I'd love to see, so hopefully you can get that answer in interval notation. That is an Algebra 2 skill. So try your best to master that notation. When I look at question 2, this is an and problem. It is written differently than or. When you do an and problem, you will never see the conjunction and. So I'm going to show you how you would write it with an and, you're still going to have positive 8 and negative 8. You're going to have a less than here and also a less than here. An and is one continuous problem, and as you can see, this says negative 8 is less than 3x minus 4, which is less than 8. To solve this, I'm going to add 4 to each part of the problem. Add 4 to the middle, to the far left, and the far right. Negative 8 plus 4 is negative 4, less than 3x, this is gone, less than 12. Next, I will divide the middle by 3, the far left, and the far right. So I have negative 4/3 is less than x, which is less than 4. The next thing I'm going to do is graph that on a number line. An and looks different from an or. I'm going to put 0, 4, negative 1 1/3 would be here. I'm going to put an open circle here and an open circle here, because when I am graphing with less than, it's always open circles. And for the shading for and, it's always together. When you are graphing an and is the intersection of these two inequalities of x is greater than negative 4/3 and x is less than 4. When you're doing an or, it's the union of the two, which means you put them together. What they have, for example, over here, when you graph x is greater than or equal to 1, you get this piece. When you graph x is less than or equal to negative 1, you get this piece. And when you put them together, you get this entire graph. This is a union, and this is an intersection. So where would the intersection of these two be? The intersection would be here in the middle. I try to remind the students that for an and, just remember that you and me, we go together. So the shading for that kind of graph goes together. The interval notation for this, do you have shading over here at negative infinity and at positive infinity and or? No, I don't. The shading on this number line reading from left to right, it begins at negative 4/3. It's an open circle, so just like infinity over here, you put a parenthesis, then you put a comma. Where does the shading stop? It stops at 4. Does it include 4 or exclude 4? It excludes 4, so you put a parenthesis. This is typically what an and interval notation would look like, and this is what typically an or interval notation will look like. So I want to make a quick note for you to remind you, when you have this symbol, or infinity or negative infinity, that's when you use parentheses, depending on which side that you're looking at. And then if you have this symbol or this symbol, that's when you use brackets. And you determine which side to put these brackets on based on how you're reading the problem or reading the graph from left to right.